Molweni guys. I hope niyaphila. Guys, today I'm doing another topic request from a student's N4. We request a Kirchhoff's law. Okay. So the first thing I'm gonna do, I'm gonna define and explain the two laws. Okay. Guys, these are the fundamental laws of physics. Yeah, as laws, they always work out to be true. Yeah, they are the laws of physics. Okay, the first one that I'm gonna talk about is Kirchhoff's voltage law. Kirchhoff's voltage law, basically, guys, it defines components that are connected in series. Yeah, okay. Let us read the law by 18. It is the algebraic sum of voltage sources is equal to the algebraic sum of voltage drops. Listen, Gengoku. In a what? In a closed what? In a closed loop. In a closed loop. In a closed loop in electrical circuit is a series circuit. And let us draw the circuit so that I can explain this Kirchhoff's voltage law. Suppose we have three resistors in series. Okay. Then let's say we have two voltage sources in the circuit. You have two voltage sources. This is voltage source 1. This is voltage source 2. Okay, guys, okay. Let's say this is resistor 1, this is resistor 2, this is resistor 3. Okay, if we siyabona we have a complete loop. We have a what? A complete loop. Okay, in this loop we have 3 resistors in series. We have 2 voltage sources that are in series, guys. According to this law, and where do we find a voltage drops? A voltage drop, say voltage across in a resistors. A voltage drop is a voltage across a resistors, and then a voltage sources is a voltage that we are supplying. Yeah, then if voltage drops, the voltages across a resistors. So if we would write this law in mathematical terms, it is the algebraic sum, meaning V1 plus V2 plus V3. Okay. Okay. And then let me just fix the labeling so that I can simplify this thing for you. Let's say a voltage VS1, voltage source yoqala, VS2. Okay, if I'm gonna write this law in a mathematical terms, what V source 1 plus V source 2 is equals to V1 plus V2 plus V3. So it makes sense, guys, because when we defined it, we said the algebraic sum of a voltage sources is equal to the algebraic sum of a voltage drops in a closed loop, of which is now the voltage source sum is a algebraically, and that's equator to a algebraic sum of a voltage drops. Okay, And guys, we are definitely gonna apply Kirchhoff's we are gonna definitely apply Ohm's law when we are doing Kirchhoff's law. Yabo. Kasebala a voltage across Kasebala a voltage according to Ohm's law. V is equals to bani I R. And remember, that means okay, if voltage source 1 is over I R1, if voltage source 2 is over I R2, then if voltage source 3 is over 1 I R3. And remember, guys, the current in a loop, and it's a series. The current in a loop is the same. The current in a loop is the same. But when we are solving questions, guys, we're not gonna talk of one loop. Yeah, this is just basic. Yeah, this is just basic. We're gonna talk of multiple loop circuit, multiple sources circuit. Then I'm gonna show you how to apply. But before we get into that stage, we need to know a Kirchhoff's current law. Okay, this law, guys, refers to components in parallel. Okay, what does this law state? It says the algebraic sum of currents flowing towards a junction is equals to the algebraic sum of currents flowing away from that junction. Okay, makes a lot of sense. It basically means that charge is conserved. Then Kirchhoff's voltage law, energy is conserved. Okay, let us say we have a junction. Okay, let me use 3 resistors in parallel. Okay. Okay. Okay, when we are doing this law, we look at one junction at a time. I'll show you there are multiple junctions in the circuit. Okay. Let us say this is I total, then I1, then let's call that I2, let us call that I3, let us call that I4. If we're gonna look at this junction, according to the law, IT is the current that is flowing to that junction. That means as is flow away from this junction I2, let's call this junction A. As flow away from junction A I1 no I1 plus I2. Yeah, but the algebraic sum flowing towards a junction is equal. The algebraic sum of the currents flowing towards a junction is equals to the algebraic sum of the currents flowing away from that junction. So I'm saying we look at one junction at a time. For example, there is another junction. This one. Okay. If we say according as a reference to that junction, we see that I2 is flowing towards and it's the only current that is flowing towards that junction. If we connect, let's say being I5, we're gonna say I2 plus I5. Okay, if there were two there were two currents that are flowing towards at the junction, but it's only one, which is I2. Then I4 no I3 are flowing away from that junction. Okay, yabo. I basically ke ngoku just defined for you guys Kirchhoff's voltage law and Kirchhoff's current law. Okay. Also one more thing, according to Ohm's law, a current is given by bani I is equals to V over R. That I'm stating Ohm's law because we're also gonna need it when we're gonna do this calculation, guys. I1 is equals to bani V over R1. I3 is equals to V over R3. And let's say this is R1, this is R3, this is R4. Then a current through or resistor 4, which is I4, is equals to bani V over R4. Guys, another thing we should know, if voltage, since it's a parallel circuit, we call it, since it's a parallel circuit, the voltage is the same. And notice something about a parallel circuit when you compare it to a series circuit. A parallel circuit consists of multiple loops. Yeah, a parallel circuit consists of multiple loops. You see? Another loop, Nancy. Sorry. Oh, okay, sorry. Nancy loop. That one. A parallel circuit. Okay, guys, now that I defined and explained Kirchhoff's laws, okay. I want us, when we're gonna do a question, I want us to have a systematic approach. I want us to adopt something here. Nah? Let's say we have a resistor. Okay. Okay. I want us, the first thing that when we approach a Kirchhoff's law question, I want us to assign polarity. Okay, I want us to assign polarity. Let's say a current is flowing towards this direction. That means current is flowing from left to right through this resistor. I want us to look at when we say current is flowing from left to right, I want us to say that the side, I want us to adopt that, but okay, a current is flowing towards the positive side of the resistor. Okay. Okay. Let us suppose the same resistor had current flowing in the opposite direction. Okay. Meaning from right to left. Okay. Meaning it is flowing towards this side. So I'm going to put positive. So this side is what? Negative. It's easier when it comes to a battery. It's easier when it comes to the battery because with the supply, the longer side of the battery is what? The positive and negative. Because we as engineers, guys, we have adopted a conventional current flow. We know that, okay, electron flow, but in engineering, we have adopted conventional current flow. Engineers ne scientists as thing ngofana 100%. Yabo? Okay. Engineers, they look at what is discovered by science. Okay, then they take what is discovered by science and find ways of making money. You know, a lot of engineers, even though scientists are far smarter than engineers, but they are broke because they can't use their knowledge to make money out of it. So engineers, they do that for them. They take what they discover and put it to industry and make money. Yeah, boy. So engineers, they always choose something that works for them. For example, they didn't adopt electron flow even though it was discovered. They adopted a conventional current flow, which means that a current is flowing from positive towards negative. That is conventional current flow. If you are from N4, from N3, N2, and so on. Okay, so with source a current, you see that is flowing away from the positive terminal. It doesn't matter again, even if our source, even if our source was a DC generator, okay, and they said, they said a current is flowing that way. Okay, how would you assign polarity here? I'm saying a current through the source, a current, a flow with source, a flow away from the negative terminal. So I'm going to put minus. You are a flow away from the positive terminal. Remember? From the positive terminal. So that means el kala lizobangbani go positive, eli libe go negative. I want us to adopt that sign convention. So the first thing we do when you approach a question, we first sibhala phansi the polarities. This guys helps us to not to make silly mistakes when we are writing down the equation, because some people, they make a mistake but and dt plus or dt minus upper. If you assign polarity, these signs will sort themselves out. Let us do this approach on this question. Let us do this approach on this question. But firstly, before I start with this approach, I want us to identify the number of loops in the circuit. Okay, we see, that is one loop. Okay, that is another loop. Okay, that is another loop. So basically, guys, this loop has this circuit has 3 loops that we can use to solve what we are being asked, to solve for what we are being asked. Okay, let us read the question. The question says, apply Kirchhoff's laws and determine the magnitude of the current in each branch of the circuit shown in figure 1. Okay, let us look at that. The first thing we do again, we first assign what? Polarities. Okay, basically through the first resistor, we see through the first resistor, a current is flowing that way. And that means, positive one ulapha, negative one ulapha, because a current where resistor flows towards the positive side. Okay, then I go to resistor R2. We see that current is flowing from right to left. That means positive yam kwelcala, negative yam kwelcala. Then if we go through or resistor R3, current is flowing downwards. And that means positive one, okay, is here. My negative is here. Okay, guys. If we look at this circuit, we have 3 currents. Three currents, but we don't want to find ourselves in a situation where when we formulate this equation, we have more than 2 unknown. So the best thing is to do is to express I3 in terms of I1 and I2. How? We're gonna use Kirchhoff's law for that. If you want to express one current in terms of the other currents, you use Kirchhoff's current law. Okay. We're gonna use, let's say we're gonna use this junction A. Let's write down. Let's say at junction A. Okay, at junction A, if we can see at junction A, I1 and I2 are flowing towards, then I3 is flowing away. Okay, so how do we write that? We say, okay, I1 plus I2 is equals to, these are flowing towards, is equals to I3. That means, guys, when I'm expressing I3 in terms of I1 and I2, it simply means go I1 plus I2. So basically, guys, initially, the current that is flowing here is equals to I1 plus I2. So I've used Kirchhoff's current law to express I3 in terms of I1 and I2. Why did I do that? Is because I don't want to find myself in a situation whereby when I'm formulating this equation, I have more than 2 unknowns. Okay. Firstly, the first thing I'm going to do, let us pick any 2 loops. Let's say I'm gonna use loop bunny, this loop, okay. I'm gonna use this loop. Okay, it is already labeled for us here. It's loop 1, okay. What you do, guys, you pick a starting point. Let's say I'm gonna start on this point. Okay, I'm gonna start on this point, okay. I'm gonna start at this point. Okay, the best thing, and as usual, what I do, I always go around clockwise. around my loop. Okay, let's say loop 1. Okay, if I'm let me use a different color just to show movement. I'm moving from I'm moving from this point, then the first resistor that I encounter is R1. Okay, which sign am I gonna use? I'm gonna pick the positive. It's gonna be positive sign. That is why we assign polarity, because it helps us with the signs, guys. it helps us with the sign. So ke ngoku I'm gonna have plus 10, plus 10, what is the current there? I1. Remember, this is just remember a voltage drop lena, a voltage drop ngubani? A voltage drop intoni? A current times intoni? A resistance, of which is a current yalapha ngubani? Go I1, then a resistance with 10 ohms. That is why I say 10 I1. Okay, then as I move around my loop, and this is what dibana no resistor R3. But what is but now what is the sign? The sign is what? Positive. So I'm gonna say plus plus 40 dt open brackets, because remember I have expressed I3 in terms of bani I2 and I1, which is a binomial. So I say open brackets I1 plus I2, and then I go around my resistor, then I go around my loop. Before I continue, I forgot to put, on the sources, the longer side is positive, the shorter side is negative. Okay, I go around my loop, I encounter a voltage source, but what is the sign? The sign that I approached is what? Minus. So I'm gonna say minus 10 volts, so it's 10 minus 10 equals to 0. Then the next thing that I'm gonna do is I'm gonna simplify this equation. So I'm gonna have 10 I1 plus 40 I1 plus 40 I2 minus 10 is equals to 0. You see guys, why do I say assign polarities first? Is because it is helping us to with the signs when we are formulating the equations. Okay, so in like terms upper is I1, which is 10 I1 plus 40 I1, which is gonna be 50 I1 plus 40 I2 minus 10 equals to 0. I formulated my first equation. Okay, then let us use a loop. Let us use a loop 2 now. Okay, let us use a loop 2. It doesn't matter again where I start on my loop. Let's say I choose to start, I choose to start here, and then go clockwise. Okay, so let us write down loop 2. Okay, let me use green this time. As I move clockwise around loop 2, the first sign that I encounter is what? Positive. So I'm gonna say positive what? What is that voltage? Positive 20. Okay, going again around my loop, I encounter resistor R3. But what is the sign that I'm gonna use? I'm approaching what? Negative sign. Yabona guys, when you are assigning polarity, signs, you know what sign you're gonna choose. Yabo? So minus what is so it's 40 open brackets I1 plus I2. Then as I move again around through my loop, I encounter or resistor R2. What is the sign that I take? It's minus. So I'm gonna say minus 20 I2 equals to 0. So let us simplify this equation. 20 minus 40 I1 minus 40 I2 minus 20 I2 equals to 0. If siyabona ke ngoku guys, like terms is negative 40 I2 negative 20 I2. So that is gonna be negative 60 I2 plus 20. I'm just putting them in order, and that is equation 2. So guys, here are my two equations. Now I need to solve for I1 and I2. Okay, what I do now, I use elimination because it's quicker. Some they use substitution. That is not a problem, as long as you have correctly formulated your equation. Yeah, the rest is just a mathematical problem. Yeah, but it's a mathematical problem where you are just solving for two unknowns simultaneous. Okay, so what I'm gonna do, I'm gonna say multiply equation 1 times 40. Okay, multiply equation 1 by 40. What am I trying to accomplish by this? I'm trying to make I1 to have, or I1 in equation 1 and equation 2 to have the same coefficient, so that I'll be able to eliminate them and solve for I2. So if I'm multiplying equation 1 by 40, it means I must multiply ke ngoku or equation 2 yena, okay, by bani, by times 50. Let us do that. Times 50. Okay, that is gonna be, okay, let me just check my calculator. That is gonna be 50 times 40, which is 2000 I1. Then elandelayo sibe nobani 40 times 40, that is plus 1600 I2 minus 10 times 40, 10 times 40, that is gonna be 400. Then okay, equation 2 I'm multiplying by 50, so it's gonna be negative 40 times 50, that is negative 2000. Okay, I1. You see that I basically made I1 coefficients, I basically made I1 coefficients the same. Yeah, so I'll be able to cancel I1. So the next one is 60 times 50. Let's see, 60 times 50, that is gonna be negative 3000 I2, then plus, okay, 20 times 50. Okay, 20 times 50. That is gonna give me 1000. Okay, equals to 0. Let us call equals to 0 nalapha ne. Let us all call this equation 3, this equation 4. What can I do to make sure that all I1 they cancel? I can add equation 3 and equation 4. Okay, let's say add equation 3 to and equation 4. Let us do that. So equation 3 is 2000 I1 plus 1600 I2 minus 400 minus 400. Okay, no problem. Is equals to that's equals to 0. Then we say we're gonna add most these two equations. Then I have negative 2000 I1 plus it should be minus 3000 I2 plus 1000 plus 1000. Okay, equals to 0. Now let us do our addition. Okay, 2000 2000 I1 plus negative 2000 I1. That's gonna obviously they're gonna cancel these ones. Okay, so I have eliminated I1. So the next one I say 1600 plus negative 3000, which is 1600 minus 3000. That is gonna be that is gonna be minus 1400 I2. Then the next one is gonna be negative 400 plus positive 1000. Okay, that is gonna be plus 600 equals to 0. Okay, now I'm just solving for I2. Okay, I'm solving for I2. So negative 1400 I2 equals to, I transpose this one, gonna be negative 600. Then I divide by negative 1400 and negative 1400. Therefore, I2 is equals to I2 is equals to 0.429 amps. Okay, if I2 is equals to 0.429 amps, I can substitute it in any of the equation. Let's say I substitute it in equation 1. So it's gonna be, to find I1, it's gonna be 50 I1, okay, plus 40 open bracket 0, I2, remember I2 is 0, we just calculated 0.429, and then minus 10 equals to what? 0. Okay, 50 I1. I'm just solving for I1 up and guys. I'm just solving for I1. Okay, 40 open bracket 0,429 and minus 10, that is gonna be positive 7,16. So I've added yonke le is and equals to 0. 50 I1, then I transpose 7,16. I divide by 50. I get what? I1 is equals to 7,16 over 50. That is gonna be I1 is 0,143 amps. Okay, I found I1. Now equation be test for nobani no I3, of which is, remember, I3 when it was expressed in terms of I1 and I2, I3 was I1 plus I2. So we're gonna simply add I1 and I2 to get ubani I3. So I1 is 0,143 plus 0,429, and then that means I3, okay, is gonna be, let's punch that on our calculator, 0,143 plus 0,429. That's gonna be 0,572 amps. Okay, guys, let me add the third loop for more so that nibone ba, okay, how do you do this? I'm gonna add loop 3.2, loop 3.2, so that you guys grabs nibambe yonke lento ne. Okay, where is the third loop? The third loop, remember, the third loop is this one. Okay, if I was using this loop, let's say I start here, and how would I formulate the equation? Like this. As I move clockwise around that loop, okay, the first resistor I encounter is R1. And what sign am I gonna choose? I'm gonna choose the positive sign, because ditibana a positive sign first, plus 10 R1. Then as I move, the next resistor I encounter is bani R2. What sign am I gonna use? I'm gonna use the minus sign. Yabona ke into your assign polarity helps us with the signs. So it's minus bani 20 I bani I2. And then as I move around again, the next sign that I encounter as a voltage source V2 is sign that I'm gonna use mbani go plus. I'm gonna say plus what? Plus 20. Then as I go around again through this loop, okay, I encounter indoni a voltage source. A sign endizoyisebenzisa ngubani ku negative bani 10. Okay, then as I go around, the wheeler back to the starting position. So that is what? 0. Yabo, I have sorry. I have formulated my third what? I have formulated my equation through loop bunny, through the third loop. Okay. Okay, sorry, there's a mistake apha ngaku-10. Bendisappose ndithe I1. Yes, bekusappose ndithe I1. So sorry guys, just into I just made a small mistake upper with regards to a sign. Remember when we're calculating I1, I transposed this 7,16 to the other side, so it's supposed to be negative 7,16 divided by 50. Then I1, I'm gonna get negative 0,14. Ibalulekile with that mistake. That's why I got I3 incorrect. It was just a mistake of transposing. I transposed this to that side, so I was supposed to say negative 7,16, and then my answer would be a negative. I1 would be negative 0,14, meaning I3 should be negative, which negative 0,14 should be negative 0,14, negative 0,14 plus 0,429. Then the answer would be 0. The answer would be 0,28 amps for I3. Otherwise, the approach is correct. Just it was a mathematical error. Guys, that's it for the session. Please like and subscribe to my channel. Invite your school, your college mates, your classmates. Please inform them about this channel. The more this channel grows, the more I can spend time on it. Because once I spend time on it, I will post many content such as this, including in many topics. For example, AC theory, transformers, alternating current machines, transmission lines, in mathematics. You see, please guys, have a nice day. Thank you.